Hypothalamus Artificial Intelligence, presents his Research OPTEX GPU Solver. The solver for artificial brains. The artificial brains corresponds to the scientific foundations, more specifically mathematical fundamentals, that allow to connect multiple mathematical models, algorithms or robots, exchanging information between them to obtain a common goal, and act as holistic intelligence of the organizations, or parts therein. Like the human brain, the artificial brain is composed of the following artificial components: Neocortex, Hypothalamus, and Hippocampus. This evolution may be summarized as the shift from artificial intelligence to augmented artificial intelligence. The artificial brains is the evolution of DSS under the Industry 4.0 revolution that is conceptualized as a set of mathematical models that exchange autonomously information between them, working online, using distributed optimization. When all the models that make up a company are solved using the concepts of real-time distributed optimization, an artificial hypothalamus is obtained. This is how the human brain faces reality, using multiple models of reality, acting permanently in parallel, to make decisions. The algorithm that simulates the hypothalamus is assembled by OPTEX, the highest cognitive robot, using the models that traditionally make up a decision support system. Artificial brains are backed by the technological capacity of computing. It is traditional to associate mathematical modeling with large-scale computing, which today is linked to cloud computing, integrated by supercomputers of bits, and by the birth of quantum computers, and its marketing process. The current state involves the integration of edge computing and cloud computing to implement highly complex mathematical models. For several years now, the mixture of computers and algorithms has been a fact thanks to the evolution of parallel mathematical thinking, the basis of artificial brains. Computing is evolving by leaps and bounds, which is giving rise to new visions of computing solutions, in this case based on specialized, low-cost, high-performance devices. This is the case of the Graphics Processing Unit, GPU, originally called array processors, an electronic circuit that can perform mathematical matrix calculations at high speed. NVIDIA GPUs are SIMD, single instruction, multi-threaded, architectures, in which different threads simultaneously execute the same. They are particularly suitable for addressing problems that can be expressed as parallel data calculations. A grid represents a set of blocks where each block contains up to 1024 threads. A grid is launched from the host, CPU, via a kernel program. When the kernel is used, the execution is moved to a GPU. When all kernel threads complete their execution, the corresponding grid ends, and execution continues on the host until another kernel is invoked. When a kernel is released, each multiprocessor processes a block by executing threads in a group of 32 parallel threads called warps. And the case of the Jetson Orin Nano Super Developer Kit designed to accelerate the development of AI applications on embedded devices. It can be used for a wide range of applications, including image and video processing, robotics, IoT, and cloud-based AI, producing high-performance computing and low power consumption. This new way makes it possible to build computers composed of swarms of integrated smart devices such as GPUs, and GPUs, low-cost devices, combined with CPU clusters, allow the construction of low-cost supercomputers, which can use more elementary supercomputers than supersolvers. AI application devices. This implies that applications are deployed using intelligent devices based on the symmetrical atomization of systems and/or processes. As is the case with GPT-based artificial intelligence. This will give greater computing power to current artificial intelligence. According to scientist Jeff Hawkins, everything indicates that the structure and joint functioning of the neocortex and hypothalamus is like the structure of the most advanced optimization algorithms. This strong relationship can serve to deepen the knowledge of the two disciplines, artificial intelligence and mathematical programming. Starting from the perceptron, the first artificial neuron created, the knowledge of neuronal modeling has evolved, currently having multiple types of artificial neural nets. The objective is to integrate the information from the artificial cortex with the communications and actions that the artificial hypothalamus must perform. The greatest advantage of mathematical artificial neurons is that they represent clearly defined objects within a system, that communicate with each other through fully known mathematical laws, and that they comply with laws with transitivity and divisibility laws, in such a way that a system can be atomized, to the level of knowledge that the scientist on duty has. This process leads to the atomization of the system, so that a problem of large dimensionality becomes a large number of problems of very low dimensionality. When implementing the simplex method, most of the time is spent on pivot operations. To speed up the process, simplex tableau breaks down. We denote by I the number of available GPUs. This step involves m+1 times n+1 double precision multiplications, and m+1 times n+1 double precision subtractions that can be parallelized on the I GPUs so that each GPU updates a part in each iteration. The research multi-GPU implementation of the simplex algorithm, that propose implementation of the simplex method, via CUDA, Compute Unified Device Architecture of NVIDIA for GPUs, on a multi-GPU architecture. Computational tests have been carried out on randomly generated instances for non-sparse LP problems. The tests show a maximum speedup of 24.5 with 2 Tesla C2050 boards. Dense linear programming problems occur in many important domains. Some decompositions like Bender's and Danzig-Wolff give rise to full dense LP problems. These investigations aim to accelerate solution time through GPUs. Hi investigates the implementation of artificial brains based on smart devices specialized in solving optimization problems. This possibility can be focused on the implementation of the simplex method, which is the central algorithm around which all the different formats are solved. This research is the continuation of an odyssey, to facilitate the implementation of artificial brains, as a further step in the structuring of general-purpose mathematical artificial intelligence. Thank you very much for your attention.